Wow, awesome. Nobody got up. Walked out the door. That's really great.
Yeah.
So when we were kids, and we were actually kids at one point, I promise, but we loved space, right? NASA, the Apollo missions, seeing people walk on the moon, Sputnik. I mean, well, okay, we're not actually that old, either of us, but show of hands. Actually, was there anybody here who actually remembers that stuff, like for real? Like you were? That is so cool. Awesome. I hope that we will actually be able to retire because there's only like a half dozen in the audience. But we did maybe like the rest of you, have you seen like Apollo 13 or something? I mean, yeah, no?
The right stuff.
Yeah. All right. Well, anybody want to work in mission control or drive a robot like on Mars or something like that, right? Okay, there we go. Get a few more then.
Absolutely,
right?
Awesome. Right? I did too. At least if I wasn't allowed to be an astronaut, I certainly wanted to work in mission control. The launch status check is one of the coolest pieces of theater ever. Capcom Go, Medical Go, some other stuff Go, like launch.
Yeah.
And so when I built my first NOC, I really wanted it to look just like Mission Control Center, and it did. It was great, but we've moved past that.
Right. I mean, if you need someone sitting in a, getting paid to sit in front of a monitor in a darkened room, just to tell you if something is going wrong, I mean, your alerts and your operating budget, for that matter, really are just not configured correctly.
Service outages, or imminent service outages, broadly reduced capacity, a data center on fire, something like that should produce alerts that page an SRE.
Right. Lower grade problems that can't be resolved by an automated response should create a ticket that gets tracked in your ticketing system.
Anything else should go in your system log, not into your inbox. Your inbox should be reserved for high value information like meeting invites.
Or 401k reminders.
I always miss those. Preferably created by your colleagues, or not, host level or service level informational spam.
Right. Alerting on any single component that has a lower reliability than the service that you're providing is just wrong, like capital W.
At worst, you want to think about reaching a threshold when too many of your components are down. And even there, you still want a velocity component on it.
Yeah, I mean, if you've got a 300 node cluster and like 10 of them have failed in the last 3 hours, you probably can just take your time and don't need to wake anybody up, particularly if you've got some automated remediation.
Yeah, but if 10 of those nodes have failed in 3 minutes, it's probably time to hit pager duty.
And I'm pretty sure that probably should hit you, not me, but yeah. Okay,
yeah, I think I'm carrying the pager today. So creating a ticket in a queue to eventually fix a failed component is fine. Putting something in the alert pipeline that wakes somebody up is not.
Right. The first alerts that you implement should be for service, like for user level experience, right? User experience alerts. Your users, are they having a problem with your service? What's the error rate, for your service? What's the latency?
Right. When I worked at Netflix, the first metric we looked at was successful streams. If the users were successfully able to watch shows, then we knew that we didn't have as urgent of a problem.
Right.
Yeah.
I mean, that doesn't mean that we don't care about other metrics, though, right? I mean, it just does, however, affect the way that we respond to issues. Individual host alerts are actually worse than no alerts. I mean, you still don't know if your service is broken.
And you still have to rely on your users to tell you whether or not it's working.
Yeah, but now you're sleep deprived, and any work you're trying to do is either being constantly interrupted, or you've just given into alert fatigue, and you're not responding to these pages anyway. So why are you continually annoying everyone in your life, including yourself?
Right. So what makes a good alert versus say a metric?
Well, it needs to be actionable to begin with, right?
Yeah, exactly. It needs to be something you can actually do something about. If not, you're really just burning everyone out.
Right, and also, I mean, it sucks when an alert goes off for something and it's only actionable some of the time, right? If it's 9 times out of 10, someone logs in, takes a look at it, and does, clicks a box and goes back to sleep, then pretty soon nobody's going to be responding anymore.
Yeah, there was a talk on this earlier today. False positives are worse than having no alert.
Right. A common case for this is teams that run afoul of their noise floor, right, where you have a time series or a log feed with hundreds of thousands of events across a broad spectrum of traffic. And the cruft or the false positive rates are actually not even noticeable, right? But if you have a slow period or your systems are looking only a portion of your traffic because you sliced out a particular customer or something, that noise floor is a bigger percentage, and suddenly you're getting paged.
Some teams will just accept that and either alert anyway or never alert below a certain threshold. And neither of those choices work well.
Right.
We've got better tools for this. Either add velocity components or, hey, machine learning all the things to solve the problem.
Yes, machine learning will save us all, I'm sure.
It's totally a solvable problem.
This isn't just a response fatigue problem, right? I mean, if you rely on humans to see the problem in large collections, large patterns in data, or to employ tribal knowledge to try and determine which graphs or alerts actually matter in a spammy system, it's going to take a lot longer for new team members to become effective, and their onboarding process is going to be pretty painful and a little bit scary, and that is not what we want when we're actually trying to attract and retain and grow new SREs.
Even if you believe that human intuition is better at picking out what your code can't, what we're talking about here is building a virtuous cycle, right? Your time is far better spent getting your alerts right, even if you have to suffer some outages in the meantime.
Right. And for that matter, you should never page on something that you can actually fix without a human being, right? If automated remediation is possible, the system should at least try it first and then only alert if that fails. How many alerts do you think you can get in a shift before you finally stop giving?
I know the third time that I get woken up in the night, I just really want to go back to bed.
Which actually is what your wife told me when I asked her.
Yeah.
But
Hey, fine, we're going with your wife jokes. Honestly, that's another thing. If alerts fire in the middle of the night, gather the data you need to preserve. Mm-hmm. Do the minimum you need to stabilize the service to the point where you're pretty sure it's not going to come back, and go back to sleep. Don't expect your SREs to root cause every minor issue that happens in the middle of the night.
Right. SREs should only be spending 50% of their time at most working on operational issues or responding to problems like this. This means that you need enough people in your on-call rotation to ensure that they don't exceed that, right? If the service is too unreliable or if your team is too small, which is perfectly understandable if you're just getting started or you've got a smaller team, you may have to get product developers or someone else into the on-call rotation until the service becomes more stable or until the SRE team is grown.
I think it's perfectly reasonable to put the CTO on the pager rotation.
Which, I don't know, that could be negative headcount, actually. Depends, your mileage may vary.
Hey, all I know is it gets more people on your team really fast.
All right, so, the idea here is that your SRE team is not just a rebranded ops team, right?
Right.
There's no such thing as a site reliability operations. Your alerts should tell you when you are having problems, and not your customers, right? And not a group of people in a NOC, staring at a bunch of screens.
I really don't think you need a NOC anymore.
No, right? And that's actually how this talk started. I mean, trust me, this is not the entirety of the talk. We talk about a lot of other things here, but basically we were both sitting around, and we just said, no, this is silly. People are, giving all sorts of talks about these, and to be clear, when we say you don't need a NOC, we're not saying there isn't, anything that there's nothing inherently wrong with having a war room or whatever you want to call it, but that even if you have one, your tools should be constructed so that they can be used for collaboration without being tied to a physical location.
War rooms really are a response to old tools and alert structures that don't work as well as the tools that we've moved to.
Right. I mean, how much better to have n pairs of eyes looking at stuff on 2 n pairs of screens than, regardless of what team they're on or where they're all sit when they're, have ordinarily going through their day, when instead of having a room with just a handful of screens and a few people controlling them.
I mean, the hacker movies tell me that you need to have 7 monitors on your desk. But having to have everyone who wants to discuss something have to be in the same room where you can put it up on where you put things up on a shared monitor and people can't poke at it is just not as good as the things we moved to.
Right. If you want to share a link to a particular plot of a time series, you should be able to post it into a chat or into some sort of an incident tool so that everyone can look at the same plot with the same filters for traffic, start and end time, resolution, all that sort of stuff.
Preferably with live data and not just a screenshot, so folks can use it as a starting point to play or dig and find discrepancies, to find alternate explanations for whatever's being held up as the current root cause.
Right, and if it's ephemeral, that data needs to be preservable with a checkbox or a flag type operation so that you can refer to it later for postmortem.
Similarly, the idea that we want fast response and communication between responders, so we need everybody together in a NOC, is outdated. We used to build Nox. When we used to build Nox, we were trying to accomplish essentially 3 things, right? A team focused on monitoring our systems, who could communicate instantly and had a shared view of the data.
Right. We can still accomplish the same thing, right, by using dedicated on-call rotations for every aspect of our service. But those folks should be able to do everything from anywhere, right, rather than twiddling their opposable thumbs in a NOC all day. And NOCs are a terrible environment for doing the actual engineering work that should be the bulk of what your team is working on. You will not build this virtuous cycle that you were talking about before of productivity if you're all sitting in a giant noisy environment getting interrupted all the time. You need to get flow, right? Although actually, frankly, OpenOffice is not much better these days. So maybe I'm not.
Yeah.
It's the one area of our industry that's like not data driven, is just resistant to that. No matter how much data you show that people are more productive when they're not in these big giant noisy environments, they just keep cramming more and more in.
Yeah.
It drives me nuts. Sorry. Get off the soapbox. But
well, I mean, you do have a point. I have worked in some NOCs that were really nice and quiet, and I could get a lot of work done. My current OpenOffice floor plan doesn't provide that feature. That said, I've responded to pages from some of the most ridiculous places. I once had to bring a site back online from a McDonald's in South Central Los Angeles.
I'm glad that worked out for you.
I mean, me too.
All right. So, if it's story hour, how about I ended up sitting on a traffic island in the middle of an intersection in West Seattle, tethered to a cell phone in the middle of a windstorm at 2 a.m. Because it was the closest place I could find a signal, and we had an outage in Taiwan. I could almost use the ping times I was getting, to time the lightning strike to thunder, as it was moving across.
Speaking of round trip time, I once had to decide if I should get off of a plane that I'd literally just boarded. I was walking on in the aisle with my rollerboard, and my pager went off, and the secondary was actually on the plane with me, so I'd figure out, should I get off the plane, or...
Of course.
So we're like...
No, let's go.
YOLO, it's fine. Hey, dude, can you move out of your seat, because I need to sit next to my friend so we can try and bring our site back online using Wi-Fi with 600 milliseconds of round-trip latency. Let me tell you, SSH 600 milliseconds, awesome.
Who actually set up that rotation, though?
Totally my boss.
Yeah, blame the manager. Typical. All right.
The buck stops somewhere else.
Yeah. Okay. Can you hit me with a slide? Okay,
yeah. Okay.
Awesome.
One next slide.
So I guess what we're really proving at that point, though, is that basically the value of a secondary on-call rotation, more even than the rest of the stuff we're talking about, right? So that you can actually, knack a page without worrying so much about these situations. But if you have that, you don't have to dump resources into creating a working environment, that won't be as conducive to the 75% of site reliability that is an incident response.
If you have concerns about ramp-up time, you can mandate that people need to be online and logged into the appropriate comms for the entire duration of their on-call shift. I won't go work for you, but you can do that.
I would point out at that point, no single service at Google, has anything shorter than a 5-minute response SLA, right? And most services have a 30-minute SLA before somebody's going to be actually actively working the problem.
Right, unless there are actual lives directly on the line. If you think your potential revenue loss is higher than Google's, fight me on Twitter.
So, going back,
I'm the Jonah Horowitz over there.
Yeah, please. It's very important which side. We should probably stand on the side that the.
Here, let's switch places.
No. Anyway. But getting back to mission control and NASA and all this sort of thing, if you actually go and watch the old movies from the Apollo missions, you'll see that even though they have all those displays, they were reacting to alarms when they took action, right?
They didn't go, something on that graph looks wrong. Everyone in mission control really meant that they all had the same information and they could respond quickly.
Yeah. They were also in a situation where actual lives were at stake, and 5 minutes just wasn't going to be fast enough.
Yeah. That rocket blew up 5 minutes ago. 4 minutes and 95 seconds, or whatever. In the SpaceX launch from February, about a year ago, there was a low thrust alarm that went off at T-1 second, and the computer aborted the launch way faster than a human being could have reacted.
I could beat that. Seriously, just how hard is that, right? Abort.
I really worry about your false positive rate, but I'm happy to give Elon Musk a recommendation for you.
Awesome. We'll hang. Yeah. Tell him I'm gonna need a lot more caffeine, like even more than I had today already. But
so better tools free us from the tyranny of fixed views and locations.
Right. I mean, so once we weren't relying on staring at the plots, looking for something weird anymore, the shared displays really kind of just devolved into a form of reliability theater, right? Where we could show visitors who didn't know how site reliability and incident response really work, how incredibly technical we were, blinky lights and full color.
We might as well have kept like a row of chrome-plated cloud racks in the corner behind glass, just so everyone could see how impressive our...
Can you chrome-plate a cloud? I mean,
yeah, I don't know.
Anyway, it makes about as much sense, though, right? I mean, and it impresses about the same kind of people who we pretty quickly decided we didn't actually need to impress. Not everybody has that luxury, but I wish they did.
I mean, I do know of a large CDN provider that only has people sitting in the NOC when they're bringing salespeople through the office.
What is that? I mean, do you think they get a SAG credit for that, like Screen Actors Guild?
An Oscar for Best Supporting Network Operations Engineer.
Best Thoughtful Screen Porter in a supporting role.
Right. So anyway, once you stop using these monitors for showing you the state of everything, what do you use them for?
Well, at first we thought we could use them to kind of let people know that there was an incident in progress, right? Sort of like the, yes, we know we have a problem, please stop calling us, banners you'll find at the top of some websites.
Right, but we find that putting up this kind of bat signal drives a completely different anti-pattern that we're all used to, which is the mob incident response.
Yeah, I mean, you know how it goes, right? Something big goes wrong with something important in your system, and an all hands on deck alert goes out, whether through pagers or email or a big Star Trek klaxon, right?
When I used to work at Walmart.com, we had like a rotating blue light kind of to make fun of Kmart that would go on whenever we had an L1 incident in progress.
Clean up on code branch 3.1.4.
Yeah, more or less. I mean, it's satisfying and it's exciting because, yes, when I was a kid, I wanted to be Captain Adama or a NORAD General too. But because everyone else on the team naturally takes an interest, pretty much your response looks like this.
Which is okay, right? If it's a quick sprint with an easy resolution, or if you happen to be a 5-year-old playing soccer. But sometimes you'll find that it drags on, right? Sucking in more and more people, and then you have no one fresh to come in and take a second or third shift.
It's far better to stick with an explicit, established incident management protocol and have the incident commander bring in the right people to solve the problem as necessary.
Right. So, since that's out, right, now we just basically use the wall projectors and the monitors for atmosphere. I mean, the team down the hall had theirs set to permanent hypnotoad for a while, which is frankly kind of terrifying. But, others just use them for bug burn down displays or, to show pictures from the, last team offsite or whatever.
Yeah, last time we moved, we were just like, why bother moving all that stuff? And we just got rid of it.
Well, you were very evolved then, namaste. We're a little more clingy, I guess. But
I mean, maybe it's just that with these open floor plans, they're moving us every 3 months. I don't know.
Yes.
So we have a refined paradigm for monitoring our systems and responding to problems, but what exactly should you be monitoring?
All right. So by now, I think most people are probably familiar with the analogy that Randy Bias put out a couple of years ago, saying that traditional system administration treats servers as pets.
Right. Traditional infrastructure is expensive and administratively inefficient. We give our servers names, we lavish attention on them, and when they suffer problems, we diagnose them and slowly nurse them back to health by, logging into them with a serial console.
I mean, early virtualization didn't really change the approach much, right? Whether servers were physical or virtual, they were long-lived and infrequently rebuilt, and therefore demanded personal attention and emotional attachment, right? Sometimes a lot of emotional attachment.
I seem to remember throwing a server off a roof once when I was done with it. Take that, Launch One.
We preferred ballistic decommissioning, but that, basically, I don't think you can do that around here much anymore. But
yeah, I think San Francisco frowns on people throwing servers off of roofs. Either way, snowflakes are bad, right? No matter what platform they're hosted on, the effort to maintain them really doesn't scale sublinearly to the deployment.
Sublinearly.
Hey, I love that word.
Well, you're probably in the right profession then. So, though I have to say, I mean, little snowflake there kind of looks hurt that you don't like her. I mean, Can you really say no to that face?
Look, I love cats, but I am absolutely done with scooping out feral server litter boxes.
Yeah, I mean, hopefully I harvested my last configuration hairball a long time ago, right? But, Randy's talk pointed to the new paradigm, which was to treat virtualized servers as cattle, right? Cattle have numbers, not names. When your cow breaks a leg or otherwise can't keep up with the herd, you shoot it in the head and butcher or render the cow and move on.
Right. The unit of administration for cattle is generally the herd. You brand all the new cattle at once, you vaccinate them at once, you breed them and feed them and harvest them in large batches, not on an individual timeline. Some things can still be handled individually, but as little as possible.
Right. So the less time you spend making changes on your servers and the more you can spend, making the configurations immutable and homogeneous, the better your cost of administration scales in relation to your workload, and the more you can get done and the more reliable you can do it.
So then Bernard Golden expanded on this idea a bit, and he made a nice comparison, saying that if virtualized servers were cattle, then containers are chickens.
Or ducks or geese or squab or, basically your bird of choice. No. Eagles are not sublinear.
Platypus?
That's not even a bird. Come on, man. I guess it's submarine maybe?
I don't know.
But it's not sublinear.
The point is that poultry grow to maturity much faster than cattle. They're more efficient than cattle. You can stack them up in less space, and you don't have to cover as much ground to manage them. Similarly, containers launch in seconds rather than minutes, and containers require far fewer compute resources in comparison to virtual machines.
Sure, but more than platypus.
Fine.
In spite of that, though, because they are so cheap, right, and as a result so numerous, you can manage them in ways that even a cattle rancher wouldn't dream of, right? In fact, you almost have to. They're designed to be immutable from the very beginning, meaning whenever you want to make a change, you don't just modify a running instance, you shoot it in the head and push a new one. Right.
In Japan, poultry farmers actually will kill off an entire coop if a single bird is sick. Which is why you can have sashimi chicken there, which is so weird. We can kill off entire clusters because immutable infrastructure and container efficiency make it easy to spin up new ones, as long as you're willing to stick by an iron rule, right. No more snowflakes.
Yeah, right. In light of the code of conduct, I feel like we should point out we're not talking about any sort of liberal millennial insert your outraged or offended group here joke. This is purely about snowflake servers, right? Servers that are unique or require special handling, especially any manual handling. It's certainly more common these days for teams to accept that every change should run through version control and configuration management, but that alone isn't enough.
You won't get very far using configuration management like Puppet or Chef as a crutch to administer tons of snowflakes, or pushing system updates rather than fresh installs.
Right. It's better to get your fleet standardized on as few platforms as possible, running idempotent pushes of hermetic build and config pairings.
I've heard of people, and maybe even worked at places where we used hundreds of Chefs or Puppet configurations to manage low thousands of servers.
Oof. I mean, that's suboptimal, right? I mean, it's nice to hire a dog walker, to tend all your pets, but it isn't the same thing as trading them in for chickens.
Configuration management is really just like the biggest trap.
Yeah, it promises to deliver standardization and automation, but it really ends up enabling the old broken paradigm to be replicated at kind of a mid-sized scale.
Like lower mid. Instead, use the benefits you can get from configuration management tools to convert your systems to immutable infrastructure.
Yeah, trivially, right? I mean,
yeah, no.
I mean, if you're running on a cloud, that means baking your machine image, with your application already on it, and an immutable container image maybe that gets hosted on an immutable system image.
And even if you're running on a bare metal infrastructure, you can do this with containers.
See your previous talk.
Right, I did a whole talk on that.
So, configuration management also doesn't scale organizationally. You have more important actual priorities for your limited resources than to teach every product developer in the company to do the Puppet DSL, let alone to learn it well.
Configuration management will not allow you to grow your operations to large scale, or to scale them sublinearly, like you could by managing immutable, interchangeable systems with an infrastructure that's not just automated, but as autonomous as possible.
Yeah, people push automation a lot, right? And automation is good and necessary, but it's not as good as a system that doesn't need automation, which is much harder and not something that many people talk about. So scripting operations that would otherwise be carried out manually, without addressing the underlying architecture that necessitates the intervention, requires significant investment. And basically, as the platforms and services change, it just gets worse.
Right. It's fragile and is prone to decay and cruft. If the team is not obsessive about keeping it in step with production, it ends up breaking.
Yes, sometimes rather spectacularly, right? And then when it does, the responders actually may find they can't easily perform the old manual process anymore, and it just delays resolution and maybe even makes the situation worse, when you end up wiping out the entire production database because the thing was pointed in the wrong place.
We've all seen things like this, right? Even with some large cloud providers. An automation script doesn't adopt the new flag, ends up breaking more production.
S3.
No.
Well, I mean, you guys are missing Tanya Riley's talk where she actually maybe talks about this exact same thing, but ends up breaking more production rather than fixing it in the middle of a crisis.
So the answer is to design systems that, whenever possible, don't require intervention.
It's good and useful to script an SQL database to fail over when it, write a script so that you can fail over an SQL database when you need to, but it's better if the service detects when it's failing and fails over automatically.
Right, but it's best of all to determine if there's a way to meet the service need without running a relational database, or to record and replicate data, without a global write master, or whatever your bottleneck happens to be, so that your data layer becomes this legion of unimportant, globally distributed, instances that you can replace in moments whenever you need.
This is a process and a mindset that's best if it's integrated from the very beginning, earliest stages of deployment and design.
Right. I mean, retrofitting for this is possible, but it involves a lot more pain. And, because every component at every stage along the way needs to be created with the idea that nothing is reliable, that any particular thing might disappear at any point in the life cycle of a service, or a host, or an instance, or a request, or a talk? Could you, no, not disappear, please, in the middle of the talk. Yeah.
Some automation can be good, for example. You have a remediation job that's triggered any time one of your Cassandra nodes fails. It wakes up, it's triggered by your alerting system, it repairs your Cassandra ring. In this case, it's a repair mechanism that enables the adoption of a resilient database.
Absolutely. And don't be afraid to automate the repair of a broken system, right? Don't inflict pain on your pager rotation just because you don't trust yourself to fix the underlying bug eventually.
Yeah, I've seen this a lot, particularly in smaller organizations that are just growing. No one wants to tell Nagios to restart Apache because they're afraid that if they implement that as a fix, then it'll become new tech debt. Instead of creating the tech debt, they burn out their production team. Or they use the terrible stopgap of making or building a NOC and mindlessly having them restart all their services all the time.
Instead of doing that, right, implement the temporary fix and then file a bug for the underlying issue. Nobody is helped by having a burned out team, and a burned out team is never going to get around to tackling that bug backlog anyway.
So now that you've built a fancy and scary autonomous system, how do you handle feature releases?
I don't know, it's kind of cute, actually. I think pretty much everyone by now should have, bought into continuous integration, at least, in principle with testing and deployment, and,
and rollback?
Yeah, rollback, yep, okay. I mean, you can't do it. It doesn't work without good rollback, right? Automating canary and rollback of builds can actually give you huge availability wins and productivity as well.
So I have no idea if this story is true, but it's such a good idea that I'm just going to keep repeating it until someone tells me I'm lying. I heard Amazon.com has automated their rollback tied to their business metrics so that if the number of billions of dollars or mega yachts per second or whatever drop after a site release, it just automatically gets rolled back.
I mean, one of these days I'm actually going to have to go find out if that's true. But I mean, the important thing is you don't need an SRE deciding whether the features of the code that are about to be released should get into production, right? You want the people, developing these features to be the ones who are seeing immediately what impact their changes are having in the key metrics for your service, whether that's watch time or service latency or mega yachts or whatever, preferably as part of their normal workflow, right? Rather than having to go looking for it. I mean, I hate it when I have to go looking for my mega yacht.
Mine is parked right on the bay.
Probably. Okay, mine's in the pool, on the roof.
There's a pool on the roof?
Yeah.
I don't have a skateboard.
I hear there's a party up there tonight.
Get me every time. Okay, so SREs at their best can be a force multiplier for your software product teams, right? SREs don't have to run services in production if it's easy for anyone to run a service in production. And SREs don't have to deploy every piece of software if they make it easy for other people to deploy code to production.
Right, which is good because from what I hear, SREs are basically impossible to hire, right?
An entire conference might have been created just so companies could recruit other companies' SREs.
Probably more than one. I think we might be onto something there.
SREs are like a super precious, we're all precious, finite resource. And so is the relationship between SREs and their dev teams.
Yeah, and while they're not the only paradigm, right, error budgets are one way of enabling product developers to make their own decisions on pushing code to production and minimizing the unnecessary consumption of both of those precious resources.
So even with that model, there are different levels of engaging with product dev teams.
Right, because your reliability team, must be consulting on every product design. But your reliability team can't scale sublinearly if they do consult on every product design. So we need a few different approaches.
The most resource intensive is the embedded SRE model, right? It allows you to get input into system design from the very beginning.
Yeah, I mean, I still use this for some high-profile engagements or where a relationship is new. We'll basically designate an engineer to join the product team for a project, attend all their design meetings, the scrums, all that sort of stuff, and basically they'll even contribute features to the product if there's something that's sort of more back-end related.
Which both boosts the product team's capacity and ensures that the engineer gets to spend some more time coding. Facebook takes us like a whole nother step. And the product teams are the production engineers' primary organization with kind of a dotted line back to the bigger PE org.
I mean, yeah, in a perfect world with unlimited resources, it's probably how we'd run everything. But very quickly, we get to a point where it doesn't scale sublinearly with the size of the org or the number of services.
So the next thing you move to is a consulting model, right? Leading to a production-ready checklist or a production-ready review, which is where you've got your service written and deployed for some definition of written and deployed, and you want to launch.
Not smoking yet.
So you sit down with the SRE team and you go through a list to make sure that it'll scale from your 10,000 beta users to your 10 million production users without driving whoever's holding the pager crazy.
Right. I mean, this does a great job of spreading, best practices and lessons learned, but it's still pretty resource intensive, both for, SRE and for the production teams, especially because it usually means that some portions of the system work will have to be redone, right? For instance, totally replacing the monitoring configurations that were used during testing and development with ones that are compatible with existing production systems.
Also, product teams on a deadline can get burned when there's more remediation work than they expected, right? And while the checklist does a great job of keeping the same mistakes from being made over and over again, it does nothing to improve old services that have already been released.
Right, so there's a degree of periodic, revisitation and outreach that needs to be done, either manually or maybe with partial automation.
But fundamentally, even this model won't allow us to touch everything that needs reliability engineering or interface with all the projects and teams within our companies.
Right. So that's why, as time has gone by, we've moved and made a big push into offering development frameworks that can be adopted by product teams without a great deal of SRE involvement. Smaller, mid-sized projects, especially can benefit where we wouldn't be able to offer one-on-one direct consulting or support early on. But if the product team implements from the frameworks, they can take advantage of a lot of built-in integrations.
Yeah, standard frameworks and templated configurations provide a paved road that reduces duplicative work and speeds up review. For instance, the load balancers are already set up correctly, the Apache and Tomcat are properly tuned, multi-region deployment is automatic, database calls are safe, etc.
Yeah, using frameworks, dev teams get quick wins for new services, and we can help improve their velocity, their ability to scale, and their availability, even if they never engage in SRE, and SRE will never end up responsible for the pager for their service. So speaking of availability, how many nines do you think are the right number of nines?
I want all of the nines, every last one of them.
You get more disturbing every time you say that. It's just a little creepier every time. How about I give you 9 shiny 5s instead?
Tempting. No.
So n plus 1 nines then?
Actually, I want full redundancy n plus n nines.
All right. So, and I seriously, I had this exact conversation with a CTO last week. But I run into people who feel any amount of effort, at least, someone else's effort, to avoid any possible, failure for their service is justified, right? So I tell them what some of you probably do, which is fine. If you want 100% uptime, the first thing we'll do is stop doing any feature releases. So if you want to get n plus n nines, how about n minus n features?
But I like features. I think instead of talking about nines, how about we talk about what the trade-offs we might want to
Okay, great, awesome, right. Yeah, so this is where we get to the point where we can have an actual discussion about how much failure we can really tolerate, right? And to be clear, that discussion should also include product management or whoever actually interfaces with customers and not just the product development team.
And the only way to do that is to figure out first, what does your service do and what data points tell you if it's working?
Or your SLIs.
Okay, Google. From there, you can talk about what impacts your customers will see if you're operating at the target values for those measures.
Be careful with the OK Google business, okay? That's kind of like shouting, hey, Alexa,
Order me a dollhouse.
Seriously. No. Hey, I heard someone's go off. That's awesome. Look, these are the jokes, in case you haven't figured it out by now. Like, it is dad jokes from here to the end of the evening, so you've been warned. All right, so anyway, once you find the set of impacts that you're actually, willing to accept and don't require a level of infrastructure that you're not willing or able to, create and support, then those target values are now your SLOs, right? Your service level objectives. And SLOs are great. SLOs are the best method we've found for reasoning about the performance of a service.
You have to think about the impact that each SLO represents and decide whether or not it's better to serve degraded results and perhaps only meet some of your requirements, or to fail a request entirely and come to an agreement with your service owners and customers on all of this. You can't let the machines decide.
Yet. I would like to take this opportunity to mention that I, for one, welcome any of our new AI overlords whose training sets include the video of this talk at some point in the future. Hi.
Hi, overlords. Cool. So the linkage between SLOs and their impact is actually really critical. You don't want to just stick a monitor on your service and be like, 99th percentile? We can meet that. Let's make that the SLO. And you also don't want to meet a service that will radically exceed your targets either, right? It's not even a question of cost or waste.
Right, yeah. I actually once worked on re-architecting a service to migrate away from a MySQL-based backend to a key-value data store. And we reduced the amount of maintenance and downtime required by that system by an order of magnitude, right? And that was in itself a wonderful thing. But we made a classic blunder.
I think I heard about this one.
What? Never go up against a Sicilian when death is on the line?
No, something about a land war in Asia?
Yeah, okay. Actually, it was only slightly less disastrous than that. We improved the system without considering the revisions to the SLAs that we had previously published that were needed, right? Which, ironically enough, got us into some trouble in Asia. We were not the only people to make this error, not even at Google. But our customers got used to relying on our delivered level of reliability rather than our promised level, which was much lower. And so we lost our understanding of the actual customer impacts that our planned failure models would incur in dependent services.
Right. An error budget is not there to be squandered, but there's no compound interest on anything either, right?
I might be able to afford real estate if that was the case.
Right, in San Francisco. You don't get any brownie points for not taking risks to improve the system. You don't even get any brownies.
Yeah, which is actually probably a good thing for me, but inevitably, the next time we incurred planned disruptions within the scope of our SLOs, we upset a whole bunch of users who had based their own system off of observed behavior rather than the kind of reasoned and deliberate process that we'd originally engaged in.
So not to be blameless or anything, but whose fault was this?
There was plenty of blamelessness to go around. Fine, fair enough. But in the end, right, nothing communicates an SLO as effectively as adhering to it and making sure that the small controlled failures, encourage the users to plan for the big ones.
This is actually the whole justification for Chaos Monkey, who I think is a really misunderstood little primate. Chaos Monkey isn't there for testing and QA. Chaos Monkey is like an enforcer. He's about setting the expectation for everyone in your organization, every developer, that they have to get it right? They have to plan for failure because things are going to fail. The big cloud providers are basically Chaos Monkey as a service.
No lie. Right. I mean, and actually, Google's moved towards sort of the same kind of thing, right? With doing stuff like Dust, which is a mini version of the big annual dirt exercises that can be run, more frequently.
Somewhere along the line, like 5 nines became the gold standard, and everyone has been cargo culting that ever since.
Right. I mean, there's probably some kind of good, fast, cheap rule to be figured out here. I guess maybe something like reliability, velocity, efficiency, pick 2.9.
It's not even just resources, though, because spending more money means having more components in your architecture. And the more complex you make your system, the more likely it is going to fail. If John Allspaw has taught us anything, it's complex systems fail.
Right, and you also have to consider the impact of an outage, right? I mean, I don't think the straight numbers tell the whole story. Is it worse to be down for 50 minutes once a year or 10 minutes 5 different times? I mean, it depends on your business.
If you're responsible for a large multiplayer online game where everybody's completely addicted and they only give you $20 a month anyway, like 95% is fine. On the other hand, if you run a payment system that processes hundreds of billions of dollars for hundreds of thousands of companies, perhaps you page on every 500.
So the response I've seen on Twitter might actually, suggest otherwise as far as the gaming goes. But I'm going to let you go on that one because the important thing is something that many people have actually realized, but which Google articulated formally earlier this year. Customer perception is reality, even when it isn't, right? And customers will measure your reliability based on their perceived experience, not the service delivered to the systems that you control.
A lot
of our services these days, have major platform external customers, right? Yours as well.
Yeah, absolutely.
With complex services of their own, depending on ours, but without the shared institutions and infrastructure that you can get between teams in the same company.
The assumption inherent in most SLAs is that we're only responsible from our edge network in. But the fact is, meeting your own SLOs is meaningless if your customers can't meet theirs.
Right. Here's the thing, and it's the end of the talk, like at the end of the day, I know, but you might.
And we're going over.
You might actually want to write this. Listen to this. Tossing your traffic over the internet to your customers is as much of an anti-pattern as tossing code over the wall to the ops team was a decade ago, right? And before anybody gets too upset, I mean, that was actually tossing code over the wall was a conscientious and well-disciplined and accepted practice back then, just like defining your SLOs and SLAs based only on the systems controlled by your own company is today.
Yeah, Dave Resnick did an amazing presentation laying out all the technical principles behind this at SRECon earlier this year. If you haven't seen that video, I highly recommend going and checking it out.
Yeah, I mean, one of the takeaways, though, is that unless you're integrating with your key customers, there's no way for them to build a system with 4 nines of availability, even if your system delivers that. Once your own house is in order, you need to get out ahead of this, right? Look at your traffic. Talk to your PMs. Figure out who your critical customers are and establish cooperation in advance.
Decide on shared metrics. You can't have a conversation if you aren't talking about the same things. Make sure everyone understands what the SLOs really mean and the on-call response guarantees that you make with those SLOs.
Yeah. One of our key external customers was Amazon, right? And we sat down and we looked at what they were doing, what they were measuring versus what we were measuring, and what the system as a whole, both ours and theirs, needed to deliver to their customers in order to, make things work, rather than just, to what we were delivering to them. So we determined any changes that needed to be made to grow gracefully together, and we rolled them out in conjunction, right? But the only way we could do that was, to commit to immediately, alerting without first establishing, whether the problem was on one end or the other, and we had to provide remote pathways to shared integration, test beds and production canaries and all these sorts of things, so that we could actually establish that kind of trust in the first place.
Put shared communication and incident response in place before you have a problem, so that you have the same kind of response patterns to your critical customers' issues as you have to other teams within your own organization.
Yeah, to truly get there, you'd have to go a lot further down this path than even we did at the time. But it is not just, even what we did made a huge difference. And, this is not just a problem for the Googles and the Amazons. They're not the only companies that need to think about this sort of thing. As demand for ubiquitous services grows and more companies build interdependent offerings, I really don't see how we're going to, be able to do anything other than collaborate, more with our most valuable customers if we want to, make this work.
Frankly, I'm actually really looking forward to seeing more companies do this kind of combined collaborative operations. I'd love to be integrated, my team, with our service providers and with our most important customers.
Yeah, what Google CRE in particular is doing may be beyond the scope needed, today by most orgs, but some of the ideas are actually readily applicable to many services, and I can't wait to see more data and specifics on how it's working.
So this talk started out as a conversation at a bar, at a conference a lot like this one, and over time it's become this talk.
It's not just an excuse to get up here and kind of like read parts of the SRE handbook to you. These are actual real ideas that we have seen proposed by speakers, by teammates, and by customers. They're not straw men, right? We've left out the names, but all these people were really actually being wrong on the internet and or elsewhere. So some of them were even us.
We've tried to reenact these conversations, more or less how they happened.
Yeah, but anyhow, it's time for us to stop talking.
It's like 5 minutes past time.
If any of you haven't heard enough dad jokes yet, we'd love for you to find us later today or tomorrow or whatever through the rest of the conference.
Or Twitter, fight me.
Or love.
Or love. I love love. Love's good.
Anyway, thank you for your time.
Thank you so much.